problematic in their own right because of that viral component, but that's a kind of more philosophical debate that also has parallels in the open source licensing of software. So one thing to mention at a kind of political level is that last week in Northern Ireland, the G8 signed up, all the G8 member countries signed up to an open data charter, which maps out these, has these 5 kind of core principles. And so the G8 is only 8 countries, but it's significant in that all of those countries have signed up to that, and it provides an ongoing kind of common ground, a common commitment to pursuing open data as a way forward. And coming back to the earlier questions, for a bunch of reasons, for improved governance and transparency, but also for innovation as well. So coming back again to the question of the commercial rationale for publishing open data, the way that I tend to think about it is this. The question you need to ask yourself is the primary business of your business or your organization selling data? If the answer is no, then you've got a great world of opportunities for open data, because that can help drive traffic to your existing channels or your existing business model. If your business is selling data, then yes, you still have opportunities in open data, but you might need to be more selective. You might need to really think about which aspects of your data you can open, which aspects of your data you want to open as a taster or some kind of map that other people can use to find the treasure, which is the data that you might not choose to license openly. And why would you choose to do this at all? Well, like I said before, drive traffic to existing channels. So a good analogy here is the Amazon Web Services API. So Amazon Web Services provide an API where you can access lots of product data, and by doing this, they enable developers to create applications that in their own domains that surface data about Amazon products and include links back to Amazon where the transaction can be performed. So by making this data available, then they've got a whole ecosystem of developers building applications that ultimately drive people towards transactions on Amazon.com or the other geographical variants. That data isn't open. It's accessible, but it's actually governed under very restrictive licensing terms, so which govern how long you can store the data, precisely what you can do with it. And that naturally restricts the ecosystem in terms of how people choose to use that. The ecosystem is sizable, but it could be a lot bigger if they openly license that. And they could, again, they could use the legal groundings, the legal frameworks to provide requirements like attribution. There's lots of reasons around open innovation, whereby people can actually publish data that's related to their business to help people carry out R&D activities outside of the organizational boundary. And they can also use that to help people spot errors with the data. So I think there used to be a myth that open content was unreliable, closed content was reliable. I think the analogy here being Wikipedia versus Encyclopedia Britannica. And I think that people have disproved the claim that Britannica was more reliable than Wikipedia for a certain set of articles. I think that's been shown to not be the case. And similarly, one of the great drivers of that is the fact that people can update things in Wikipedia. People can fix bugs and errors. But what we don't often see with data is decent mechanisms by which people can identify errors and then feed that back to the people who are responsible for maintaining the data. And I think perhaps the most compelling is that reason for publishing open data is that you can also transform your own organization's operations, your own business. So to give a nice example of this is a map of the UK plus a bit of Ireland. And this is a visualization that was done by one of the startup companies based at the Open Data Institute. And every month in England, not the UK as a whole, but in England, the National Health Service publishes a list of a data set defining all the medical prescriptions that have been written by doctors. So this says who the doctor was, which practice they work for, what drugs they prescribed, and when. It doesn't say anything about who they prescribe them to. It's not personal information from that point of view. So all that personal information is stripped out. But this provides an incredible perspective on on the prescribing activity of drugs of doctors in England. And what this company did with our support was they took this data for a period, I think it was 1 or 2 years, and they looked at all the cases where doctors had prescribed a patented drug, a non-generic drug, where there was a pharmacologically equivalent generic. So you've got patented drugs which are typically very expensive, and you've got generics which are typically very cheap. And they looked at all the cases where a patented drug had been prescribed, where there could have been a generic prescribed instead. And they controlled for all the cases where there were slight differences in side effects or drug interactions in the patented cases, or that justified prescription of the patented drug, removed all of those and looked at what was left, and then counted the cost of prescribing those patented drugs when they could have prescribed the generics. And the cost savings that they identified in this project was £200 million a year for one drug class, just in England. I kind of need to emphasize that £200 million in 1 year. This is an absolutely phenomenal amount of money. And this is a great example of how, by publishing the prescription data, the National Health Service can find out things that it didn't know about what's happening within the organization, and then can use that to transform its own prescription practices or the guidance it gives to doctors about which drugs they're prescribing. It also highlights some really interesting regional differences. So this is London and the southeast around here, and there and in the northeast, in this area here, you can see that there's a very high percentage of prescription of the proprietary, the patented statins, whereas in other areas it's much lower. And we don't really know what causes that. We don't know what drives that difference. One hypothesis is that the representatives of the drug companies, like the sales team in these areas, are very effective. We don't have enough data to understand whether that's really the case or not. It seems a little bit unlikely that that can explain all the variation, because presumably these proprietary drugs come from more than one company, and therefore you'd have to have precisely the same patterns of effective sales forces in this area and this area across all drug companies, which seems a little bit unlikely. But we need to understand more about what's causing that kind of variation. Or the NHS the National Health Service needs to understand more about that. And there was one other point to make, which I've now forgotten. Yeah. The other key point is that this is something that is really informative for the National Health Service. This is something that the drug companies can also use to understand the performance of their own sales teams. So in this case, they could say, actually, these guys working here are terrible. Like we need to sack them or pay them more money to motivate them more or something. But either way, we're not making much money in the East Midlands. So this is one of the challenges of open data, that you could say, well, it's good for the National Health Service, but it also helps the drug companies. But the difference here is the drug companies already know, they already have the data that tells them how effective how many units of the drugs they're selling in each location. They don't really need any help. If they're not using it, then that's their problem. But here, this is about a public sector organization releasing open data, and then someone else outside of that organization performing this kind of analysis and potentially saving £200 million a year. So open is great. Open is necessary. Open and clearly licensed data is essential if you want people to really build applications on top of a web of data, but it's not sufficient in its own right. So, I think I'm well ahead of time, so I think we have some time for some questions. Yeah. Good. Yeah.
Get insights into their competition, and isn't that is that okay? Like I know, like Tylenol can get in how much of Motrin is being sold.
Yeah, that's a good point. I think they could. I think that's okay. if that means that they compete more effectively between themselves, then maybe ultimately that's going to drive some cost improvements, which will lower the overall cost for the health service as a whole. I don't have any philosophical objection to that, but it would be an interesting topic for discussion.
Hi, nice talk so far. Any comments on the authenticity and veracity of the data that's published? Is there a visa which can sort of authenticate or say that the data published is right?
Do you mean about this?
In general, when you're talking about open data.
So that's a massive issue. So one of the things that I'm going to talk about in the next section is to really look at how look at a high level about how there are some mechanisms for identifying, providing that kind of provenance information, and therefore providing a degree of authenticity. So there's two aspects to that. I think one is where has the data come from, and how was it actually collected. So one of the great things about the web is that, and especially as we apply the principles of the web to the data itself, then we automatically get a mechanism where we can trace back the source of the data. So if you imagine a spreadsheet or a CSV file flying around the web, it ends up on my desktop, and I lose all the context of that. If that is in RDF, then I have basically claims in the data that are or data points which are encoded as URIs, and I can trace that back and look that up and say, is that what this source actually said? I can verify the data that way. So that provides some of the authenticity. What we don't have in this mechanism is any guarantees about the veracity of the data. So what we can do is represent where it came from and describe the collection protocols for that, what assumptions were made, what instruments were used, describe the inherent errors in that data that we're aware of from a protocol perspective, and describe that. But ultimately, we have to trust the source of the data. If I can read someone's description of how they collected the data, and I can choose to believe them or not, but ultimately I have to make that decision myself.
One comment on the first half about embedding data within HTML we talked about. At some point, I think like a couple of years ago, eRDF was becoming sort of more prominent, and browsers were starting to implement. I don't see anything in that direction happening now. Embedded RDF, eRDF.
Yeah, I didn't.
Escape was implementing.
Right, I didn't catch the full question, but I'll repeat it back. And you're asking about the status of eRDF?
Something like
that.
Why did it die, and if it died, and so on.
Okay, so thinking about the microformats, taking that as a basis, then we saw an evolution of trends from that to, through microdata, which is an HTML5 working group proposal about embedding structured data within HTML markup. Somewhere between that came eRDF, which was an attempt to do the same, to be able to embed RDF data within HTML. It was one attempt that was created by my former boss at Thales, Ian Davis. And what happened after eRDF was that the W3C came along and created RDFA, which is, again, a now standard way of embedding structured data in HTML documents. And I think we can see that everything that was learned from microformats and eRDF informed the development of RDFA. So eRDF itself is now obsolete, but RDFA can be seen as a natural successor to that. And I'll talk a bit more about RDFA in a minute in the next section, as one of the ways of serializing RDF data. Yeah, one more question over here.
So
Could I just ask, can I have the spotlights down a little bit, because it's hard to see the audience. Okay, thanks.
So, in one slide you showed how a company can go about, deciding whether to and how to, make the data open, right? And depending on whether selling the data is the primary business or not. So, I'll use a specific example and try to understand that. So, let's say we're talking about a website that, publishes articles. and
Articles, did you say?
yeah,
Research articles.
articles, and then it earns money by advertisement, online advertisement, right? And I think such a website should have a problem if there is another website which steals the articles and publishes it and earns money in the same way, or even if it is not so. However, that I will imagine that such a company will not have a problem if somebody derives information from the articles and does build some interesting application on that, right? So what kind of license such a website can use to enable the users that doesn't hurt it vis-a-vis the users that hurts it?
Right. So it's a really good question. I think it has two parts. One is what strategy should the company use in licensing the data about the articles, and then what strategy should they use for defining how the contents of the articles can be used for derived works, right? Okay, so I'll answer those two different bits separately. So in terms of the first one, the best reference point that I have for this is what the New York Times have done. So they've been publishing openly licensed data about their archive of articles for a couple of years now, 3 or 4 years, in fact. And the way that they describe it, the way that they sold it to the executives was that we can give away the map, but we don't have to give away the treasure. So they see the treasure as their 110-year archive of news stories, and they'll still charge for access to those, but they've openly licensed the data, which they describe as the map that helps people find the articles. So I think from a journal publishing company or proceedings publishing company, that's a nice scenario that they can use, because then, like with the Amazon case, if other people create applications that drive traffic to their existing channels, then they can monetize them in conventional ways. In terms of how to license the use of creative works for data mining or something like that, then that's a really complicated area that's still poorly understood. My guess would be that any of the large publishing companies would be very reluctant to license the content of their articles for data mining purposes. So on a large scale, because they still see this as the kind of, they probably say, well, we want to do that. That's our value to derive from that data, from that content. And when I was working at Thales, we had a big sample of data from one of the big publishing companies, and they were, with some persuasion, they shared that with us. But they were very clear that that was for our internal research only, and there was no chance that that would be published more openly. So commercially, I would expect people to be very sensitive about that. From a legal perspective, then we've got interesting debates going on in Europe at the moment about licensing exemptions for data mining, for creating derived data, and it's not clear what the outcomes of those will be. It's an active area of discussion at a kind of political and legal level, so it's too early to say. But this is an example of precisely where the law and the understanding at a policy level is way behind the field technically. Does that answer your question?
In case of data ecosystems, you mentioned about the licensing simulations. The simulations you have done. What are the parameters you take to fix the simulations? Licensing simulations. What are the parameters you take to do the simulations?
Right. So the inputs are basically the proportion of. If you run the simulation, then it basically starts with a certain number of data sets, and then randomly adds data sets from the different categories, and sees whether they can connect to other data sets in particular ways, where the different categories will be the commercially licensed, non-commercial, commercially licensed, the viral, and the attribution only. And then they attempt to randomly attach to different data sets, and that evolves, and then at some point it reaches a certain steady state. But there's lots of other parameters, and I'm not sure that all the parameters are the right ones. So we've got things in there like whether things are from the private sector or the public sector. And I'm not sure whether it's necessarily, whether all the inputs are meaningful. But it's a work in progress that we are exploring as a way to help us understand and visually illustrate to people how the restrictive license is, whether that's restrictive virally or restrictive commercially, actually limit the growth of that ecosystem or the connections between that. So to give an additional bit of background, the reason we created this was to really help illustrate. Okay, so in the UK, there's lots of arguments made about the value for the economy of open data is, $1 billion a year, or 10 billion, or 1 million, or whatever. And every now and then you get a study from a large company that say, we've studied the market and we think the potential market for open data is this, and they attach some semi-arbitrary figure to that. And these numbers are almost impossible to verify, and and ultimately it's hard to generate any real meaning from that and any real understanding. This is an alternative approach we've taken to try and communicate to policymakers about the way in which, or the reasons why open licensing is really important in terms of the growth of that ecosystem and the economic benefits of that. I can point you to the link and you can have a look at more of the inputs and experiment with running it if you like. Okay, let's take a break, and we'll come back at 11:30. I think we could take a 11:15. Yeah. Okay, let's come back at 11:15 then.
Those of you who haven't yet started following us on Facebook, please do that. It's facebook.com/Yahoo Summer School 2013. You can find all the session details along with timings on Facebook. We had a 2-week-long campaign running, and there are 5 folks who have won a Yahoo goodie. And we'll be kickstarting with our next campaign starting from today. What you'll have to do is summarize your key takeaways from each session and post it on Facebook. And the post which gets the highest number of likes and also decent conversation going will stand to win a goodie. We will also have a subject matter expertise who will review your summary. So if it's in line with what you have heard here, plus also popular, then you'll stand to win a goodie. So get started with that starting from today. Watch out for that. And just a request, secondly, if you are asking a question post any session, please speak into the mic. We have a recording happening here and it will help us capture the entire conversation. Okay, thank you.
Okay, everybody, welcome back. Can someone at the back raise a hand again if they can hear me? Okay, I think maybe I need the mic up a little bit more. Can someone try again at the back? Any? Yeah? You saying higher, Natasha? More volume, okay. Okay. Right, so this next section of the talk is much less about history and legal complications and much more about the technology we're going to use to build a meaningful web of data. So we need to revisit the principles that I proposed earlier on about that will guide how we create this web of data. And remember, these were accessible, the web data should be accessible and usable at scale. So how have we performed so far by introducing an open data element to that? Well, for it to be open, it needs to be openly licensed, but it also needs to be open in that people can reach it. So we've handled the accessible part of accessible. We haven't yet dealt with the findable part. So in terms of usability, then by openly licensing our data, then we've given people clarity about how they can use that. So we've covered the legal aspects of usability. We haven't yet covered the technical parts. So related issues to this are that we need to ask ourselves, is the meaning of data published on the web clear to potential consumers? Can that meaning be discovered? And is it possible to do this at web scale? So by doing this at web scale, I mean, we don't want a human being to be having to sit down and interpret the column headings in a CSV file or read some explanatory notes embedded within an Excel spreadsheet in order to make sense of the data. We want it to be published in some standardized way so that all manner of different applications can come along and find that meaning, can find that definition of what the data actually contains, and therefore, by being standardized, we can do this on a massive, massive scale without human intervention, which is precisely the kind of thing that's going to have to be required to implement semantic search on a scale. We can't have human beings sitting down kind of classifying stuff. It's just not going to work. So part number 4, the web of open data. So to ground our understanding of why the RDF data model, which I'll talk about in a moment, is so important and so powerful, we need to understand what it's competing against. So if we think about other formats that might be used for publishing data on the web, we could say, well, Excel, CSV, JSON, or XML. Let's look at how these compare to RDF. So let's take Excel. Is it an open standard? Can anyone adopt that? And is it fully documented? Can anyone build tools that work on that? Does everyone have the rights to use that standard? And will it, if it's going to be changed, will it be done? Will the changes be made through a well-documented and well-supported community process? The answer for Excel is clearly no. It's a proprietary Microsoft format, or the underlying Excel format is proprietary, and it means that people can build tools, but there's always a risk that that format will change, the tools will break. Does it contain native links? And what I mean by a native link is that if there's an application that's processing some data that contained in an Excel spreadsheet, is it clear when the contents of a cell should be interpreted as a link, or when it should be interpreted simply as text? And the answer is, in the case of Excel, is no. So yes, you can have spreadsheet cells that include an HTTP URI, but there's nothing inherent in the format itself that says to applications consuming that data, this is a link, go and follow it if you want to. For applications to do that with Excel data, then they'd need to look at the contents of every cell and say, and do some kind of regex on the contents of that cell and say, does this look like a link? Is there a string here that starts HTTP : whatever? If there is, then maybe I should look this up. If there isn't, then I shouldn't look it up. But there's no guarantees that if it's not, anyway, yeah. The answer is it's complicated. Yeah, there's nothing inherent in the data format that says this is text, this is a link. Is the context included? And by context, I mean, is there anything inherent in the data format itself that gives context to the data, that tells people that are consuming that data what it means, where it came from, how it was collected, what the relationships are between different elements in the data set itself? And the only answer to this is that there's context only by convention. So it's conventional in a spreadsheet that you have some column headings that give some basic indication or description to a human being of what the contents of those columns are, or what the cells in those columns are. But that's just by convention. And any of you that have worked extensively with spreadsheets, and if you have, I apologize, I feel your pain, then you know that people do all sorts of other things in spreadsheets. It's not strictly analogous to CSV. People write explanatory notes, people do formulae, they embed charts, they do all sorts. It's not a particularly, in terms of how it's used, they're not particularly regularly structured. And the scope for embedding context information is probably limited to people using a cell to type some notes saying this data was collected between 2010 and 2012. And if you look at a lot of the data on data.gov.uk and the other national data portals, and often there'll be spreadsheets on there where there's summary statistics. and then explanatory notes at the bottom, and then perhaps perhaps a key that defines what some of the abbreviations in the data actually mean. And that's all there embedded in the spreadsheet. It's context, but it requires a human being to come along and interpret that context in some meaningful way in order to understand what's going on there. If a machine comes along, looks at the contents of that, it's not in a position to do anything meaningful with that data because it just appears to be a set of characters. There's no inherent structure in there that's machine readable. So if we move to CSV, then we get into a slightly better position. So there is an open standard that defines CSV. Again, it doesn't have native links. So again, the contents of a cell in a CSV file, it's not immediately apparent to an application consuming that data whether that's just a string or whether it's a string that also there's a link that should be followed. So in that sense, we're no better off than with Excel. And with context information, then again, the context that describes or defines what the data means is only included by convention. So it might be that the first row, and here the conventions are a bit stronger. So it's a fairly strong convention that the first row in a CSV file may be the column names. It's not guaranteed, but so again, if it's a human being, you have to look at that and say, is the first line of this CSV file the column names? There's not much scope for having more kind of richer contextual information in there. And in a sense, that makes it cleaner because people don't misuse the format. It makes it cleaner tabular data, but it limits the extent to which you can embed that contextual information like explanatory notes or keys or whatever. So if we move on to JSON,